and Adesuloye. This is my occupation. I received salary and I'm in this department. I can have somebody else that is in that department, in that my same department. Oh, Joshua, this is also doing this and is in the same. So department can appear more than once in this table, but it can only appear once in this table. So that's why it is one to many. This is also one to many. So that being said, this explains the connection. And that's why in our presentation, I told you about entity integrity and referential integrity. Now, referential integrity is the connection between the tables and how foreign key must match primary key. So that just to tell you how it works. This is a connection, yeah, and one to many. And this is a snowflake schema. And let's just go on from. Sorry, give me a minute. Okay, thank you. Let's just go on from there. Okay, let's go to the presentation. So we just designed a relational data. Create your tables. Let's go back to the interface. You create your table, you insert into your tables. So we've just done that. So that we've created a database schema. That's just the pictorial, just the way we can do it. So next thing on our let me go back. The next thing on our objective, we've done read and write operations. We've done this. We've done this. We've done this. Now the next thing is the indexes. So indexes is simply a data structure that improves the speed of data retrieval. You know when I talked about read and write operations, now read operation is when you want to retrieve a data from a database and you want to use it for analysis or for reporting or for whatever. And so it improves the speed of data retrieval operations on a table. Indexes are like table of contents. Now, when you open a book, you have the table of contents. So when you want to go through like chapter 5, you know the number that chapter 5 is. So you just open to chapter 5 straight up. You don't have to start going from the beginning, opening each page and checking for chapter 5. That's what indexes does. So instead of scanning every page or every row in the table, the index points to the exact location where the information can be found. So making retrieval is much more faster. Now, indexes are useful when you are frequently running queries with condition that involves filtering large data sets. Now, because of this, our data set is just how many? Just 12 this thing, 12 rows. Might not really, I'm going to do it though. I'm going to use my SQL to do it, but it might not really show us what we want, but we'll still do it. So indexes are always used in large data sets like millions of rows. And instead of doing a read operation and saying, oh, select this from this, where this is this, and instead of the SQL, the database, the management system going from the beginning of the row to the end to where you're looking for something, the index just makes it faster, yeah. And indexes on foreign and primary key can significantly speed up join operations between tables. So the places where indexes are useful are for looking for something, running queries where you are looking for something, or you are filtering, or to speed up join operations. And the syntax for index is create index. So before we go to, there's a downside to index, yeah. But before we go there, let's just try it in my SQL. I already wrote the syntax down. Preparation for this also. So we've inserted into this. So create index. Before I do this, let's check the way you would know that an index has worked here. Because this will work originally, but because what index really does, it saves time. It's faster. So what we're going to know if the index really worked is to check the time that it took. So before we use the index, let's first do normal select from. Come, give me a minute. Um, Okay. Select from employee demographics where this is a filtering operation now, where first name is this and last name is this. Remember when I said indexes are useful for when you are trying to filter? Yeah. So what this does now, let's first do this one anyway. So I stop talking too much. So yeah, when you select from, it does this. And you can see you used 0.6, like I said, this database is small, it's tiny. So you use 0.062 seconds to look for this. Now let's impute create index. Let's create index on. Now what this create index is saying, let me explain what it's saying. This index will help us speed up queries that filter employees by their first name and last name. So create index, this is the syntax. Create index IDX on the employee name. Yeah, on the employee name, on employee demographics. This is the table, employee demographics. So in employee demographics, we are putting this index on their first name and their last name. So what this really does is that it helps speed up queries that filter employees by their first name and last name. So let's impute this. What I did first was just do this so we can compare the time difference, because that's what index really does. It just fasten the time. So we've created the index. Now let's start creating the index. Let's do this. Let's do this and compare. Now before you use 0 points, you used 0.062. Feels like it increased instead of decreased. But yeah, you use 0.62 seconds and now it's using 0.119. It's not supposed to increase. Let me do it together. Oh, duplicate name. I'm not supposed to do that again. I'm not supposed to do that again. Okay. Let's drop. Let's start from beginning and drop this. Let's drop this and do it again. Again, that is why drop if exists is useful. So you can always start again. It's as if you are creating all of those things that were created, you're creating it all over again. So let's okay. I'm trying to compare because that's when it makes sense. When you compare. Okay. You use just 0 second. How are we supposed to even compare? So let's create index. Let's create index and do it together. Let's see. Okay. Now, let me explain. So you also use 0 points. You can't see the difference here because um, it's a very small data set. So you can't really see it. But if it's like millions, that's when it's very useful, like I said before. Now I want to talk about, I'm not supposed to talk about the downside of index here, but since it's here, let me just say it. Now, when you create an index, it uses a lot of power, like it uses a lot of space. Can you see now? You use like 1.1 second to create an index. Yeah, and you use 0 second to do this. So the downside of creating index is good. Yeah, it's good. But the downside is they slightly slow down the right operations. Because when you use inserts, when you use indexes, it's it improves the speed, yeah, but you use a lot of space. And so it slows things down. That's what it does. It slows things down. Let's go back. I want to give you instances of where you can use indexes here. So you can use indexes on first name and last name to find something. Something that you filter a lot. You know that okay, in this database I used to filter names a lot. Maybe I'm very interested in area where they live. So I'm always filtering areas. I want to know what happens to people that live in this area. You use area a lot. So you can always put an index on the area. Okay, index IDX. this area on the table, and then you can put the area table, the area column there. You can put an index on that. So it is easier for you to find it. Yeah. Because when you work, you won't use database that has six rows. You will use millions. So you need to work on time. That's what create index does. So the next create index we're going to use is the index on employee ID. What this does is I want to use it on a join. Yeah, we've used it on first name and last name where we use filtering. I said it is good, it is useful when you filter, it is useful for joins, and it is useful when you're looking for something. It's faster to get it. No, the second type of index I'm going to show you now is creating an index. Excuse me. Second type is index that optimizes queries that join two tables together. Now, you want to select first name, last name from the employee demographics, and want to select salary from employee salary. So employee demographic as D, join. I'm sure we know our like traditional join syntax. Join salary as S on we're using the employee ID in demographics and employee ID in salary, where salary is this. Now let's do just this to compare. I hope it shows something. So this used 0.156 seconds. Now let's create an index on employee. Now we're creating an index on employee ID of the employee's salary. Why am I so clumsy? Okay, so we created the index on employee's salary. Yeah, this is the table. You always create, when we did it here, we did it on employee name. The name of the index is IDX employee name one. Then we state the name columns under the table. Then when we do it here, we name it index of employee salary. Then we use the employee ID in the employee salary table. So let's run it together and see if there's a difference. Now, so when we first did this is the first one that we did without the index. It returned this 0.156 seconds. But when we did it with the index, you see that we used we didn't even use up to 1 second, up to 0 point something second, in fact. So that's what index does. It looks for something fast because it just points to where that thing is already. It doesn't have to scan through the whole data. It just goes straight to where it is. That's what an index does. Now, this is the second example. You can use index again for filtering. You can use it in joins. That's what I just did now. You can also use it. Sorry, give me a minute. We can also use it in um please, if what I'm saying you understand, please raise your hand. If you don't understand, I'll do it again. I'll go over it again. If you understand, please say something or raise your hand so I know that I'm communicating. Okay, great. Thank you so much. So, yeah, we've seen how index works in when we want to um when we want to filter, and we have seen it how it works when we're doing a join. Now, the third scenario for index is when to optimize queries that filter or group employees by their departments. Now, see, when you want to use group bias, yeah, you know that when you use group bias, it will first do an aggregation, then to group by something. And you know that that takes a lot of, should I say, a lot of effort from database. So it will take time to do that because it's doing aggregation first and then it's grouping. But when you put an index on the department ID, yeah, from the department salary table, it just points to it. Yeah, you don't have to, it doesn't have to do too much. It doesn't have to go over everything, then do the aggregation, then group and all of that. You just go straight to it. Now let's do it without the index and see. Oh shit. Okay. Sorry, I swear. Let's do it without the index. Now, this is our average salary and department ID. And okay, we can see that it used 0.046 seconds. If this data this thing was bigger than this, it would do that in, I don't know, it would show us difference like, well. Now let's do it with the index that we are creating. Let's do it with the index. It's running. Now with the index, you can see that it used just 0.000 second. Didn't do too much. It just went straight to that place. So you can see how index helps. Yeah. From my write up, you can see that I said an index helps with, instead of scanning, it just helps with finding, with retrieval much faster. That's the point of index. It's faster. Yeah. And it helps when you are filtering. It helps um when you are doing using joins, when you're doing join operations and when you're looking for something, it just helps to make it faster. But the downside to it is, like I said before, it slows down write. Okay, you know when I talked about read and write operations when we started, that's why I started with that. So you guys know that at the end of the day, everything that is done in a database, in a data environment, is either you are reading or you're writing data. When you read it, you're trying to get data, you're trying to retrieve data so you can use it for analysis. When you're writing, you're trying to add or modify the database. Those are the two things we always do in a database environment. So indexes will improve your read performance. Read performance is what you're trying to, what we did here now, all the things we did here now, their read performances. Yeah, all this select, select, select. We're trying to read it, we're trying to get information and use for analysis. Yeah. But since, yes, indexes they improve your read performances, but they slow down your write performances. Yeah, because anytime you are inserting, you are updating, you are deleting, your index must also be updated. And it takes a lot of power to do that. So it will slow down your write operation. So that's why this that's why this was there. Because when you try to optimize write operations, it has an effect on read operations. When you try to optimize read operations, it has an effect on write operations. Yeah. So that's the downside of indexes. Now, indexes improve the speed of data retrieval at the cost of additional storage space. Now, you know that indexes they help with this relational database that we did. Let me I want to show you something else. That reminds me. Now, your database will also show you where their index is. You can see that it's showing index. Your index is on the primary key. The index is on the primary key. Let me put this up. The index is on the employee ID and the department ID, which are the primary keys of these both tables. So you can see that when I was saying that, oh, it shows the index. I don't know where I said that. I can't remember, but I was saying that it shows your database shows the indexes. Yeah, it shows your tables, it shows your, I think that was when I was explaining database design, that it shows your tables, it shows the columns, it shows the relationship between them, it shows your indexes. So they are all connected. So indexes helps to optimize relational database, helps to optimize your read operations, but it is at the expense of additional storage space. Yeah. So when you are inserting, you are updating, you are deleting, there is a slowdown data. So that's the downside. So and that ends this session. There's a practice exercise here where you design a new relational database schema for a simple library management system. You just follow what we did here. You're going to get it. There's no big thing to it. If you just follow it, just when there's an error, you can see that when I had an error, I had to check what the error is about. You can always troubleshoot. There are always errors. Even people that have been working in as data analyst or data scientist for a very long time, they always get errors. What you have to do is check the error and see what the solution is. Then when you get check an error, just go back. Maybe I will share the script of this and see, oh, what happened here and all of that. So there's an exercise again, like I said, and you're designing a new relational database schema for simple library management. And you're going to write an SQL to create the database schema with multiple related tables. Now, you're creating a database, then you're creating tables, and then you're going to obviously impute values into the tables. Then you define your primary and foreign keys for each table. You define that and then you do a connection. Then you create indexes on the key columns for optimizing common queries. Now, another thing, indexes, they are great for common. If you know queries that you know that you do a lot, just put indexes on them so that you're faster. So I think that's the end of this session. Yeah, I'm going to also share the slide. There will be a last session, I think on the 8th, but I don't know, I might move it to 9th because I have a lot to do. But yeah, and I'm so happy that you guys like joined in and you, I don't know if you enjoyed the class, but yeah, you joined in. So if you have a question or you have something you want to ask me, you want to say, just say it now or just ask me. You can just rapport and no, just yeah. So is there any question or anything you want to say or anything you want to ask or you don't understand in everything that I explained? Okay, I think there's no question. Okay, that sums it up. I think we're done. I think we're done. Thank you so much for thank you so much, Bushra, for staying and see you guys on the 8th or 9th. Yeah, thank you, Bello. Thank you, Bushra. Yeah, bye.